Have you ever wondered why a solid sugar cube takes much longer to dissolve in water, but powdered sugar vanishes almost instantly? Hi, I'm Kiran. Today we are going to crack the code on this sweet puzzle together. It all comes down to two awesome science concepts: surface area and the concentration boundary layer. Let's dive right in. To understand this, let's quickly learn three science words. The sugar is our solute, the substance being dissolved. The water is our solvent, the liquid doing the dissolving. And together they make a sweet solution. The simple answer to the effect of surface area is that when you use powdered sugar, a much larger surface area of the solute comes into contact with the solvent. Because the water has more area to attack, the sugar dissolves much faster. But why is the area bigger in powdered sugar? Let's prove it with some quick math. Imagine our sugar cube has sides that are 6 cm long. A cube has 6 faces, right? To find the total surface area, we first find the surface area of one face, which is 6 times 6, equaling 36 square centimeters. Multiply that by 6 faces and our total surface area is 216 square centimeters. Just a quick note, if we calculate the volume, which is 6 cubed, it is also 216 cubic centimeters. The surface area and the volume numbers only match here perfectly just because we took 6 centimeter cube. Try the math with 5 centimeter cube or 8 centimeter cube and see what happens and how you get the surface area and the volume. Okay, we have 216 square centimeters of area for the water to touch the sugar cube. Now, what happens if we break this exact same cube into 8 small equal cubes? Because we have exposed the inside of the original block, the total surface area jumps up. Let's calculate. The side of each small cube is now exactly half of what we have earlier, so 3 centimeters. The area of one face is 3 times 3, which is 9 square centimeters. Multiplying that with 6 faces, and the surface area of one small cube is 54 square centimeters. Since we have 8 of these similar cubes, we multiply 54 by 8. The new total surface area shoots up to 432 square centimeters. We just double the area the water can touch, which means it dissolves twice as fast, approximately. And guess what? The total volume of this sugar remains exactly the same, 216 cubic centimeters. You can pause the video and try calculating the volume of each individual small cubes and add them together. You will find that it is still the 216 cubic centimeters. So when you use the powdered sugar, you are basically breaking that single cube into thousands of tiny pieces, creating massive surface area for the solvent to attack. Now let's look at a visual that explains how the surface area changes with the number of divisions per axis changes. If you have a single cube with side length 6 centimeters, the surface area is 216 centimeters. When you change the number of divisions per axis to 2, you get 8 cubes and the surface area changes to 432 square centimeters as we just saw. And then when you change the number of divisions per axis to 3, the surface area you have now is 648 square centimeters. If you change the same to 4 divisions per axis, now you have 864 square centimeters. And if you change the same to 5 divisions per axis, now you have 1080 square centimeters of area. So see, without changing the volume, by subdividing the cube of sugar into multiple pieces, you are increasing the surface area. As you go on doing this, the powdered sugar will have much more surface area than a single individual cube. And remember, this isn't just about sugar. This is the exact same reason why cooking works the way it does. If you try to boil or fry a massive whole potato, it takes forever. When you finally bite into it, the middle of it might still be raw and hard. But when you chop the potato into small pieces, you increase the surface area. The heat can reach more of the potato at once, so it cooks much faster and evenly. But wait, there is a second reason the solid cube dissolves so slowly. It's a fluid dynamic concept called the concentration boundary layer, or we can call it as syrup shield for now. When the solid sugar cube sits in water, the solvent immediately touches it, quickly dissolving some solute and gets completely saturated. This creates a heavy invisible shield of thick syrup hugging the sugar cube. Because this boundary layer is already stuffed with sugar, the dissolving process hits a massive roadblock until this thick syrup slowly drifts away to let fresh water in. But when you pour in granular or powdered sugar, something entirely different happens. The tiny crystals scatters everywhere inside the water. Almost every single piece is instantly hugged by fresh water, the hungry solvent. Because they are spread out, that thick syrup shield never gets a chance to form. The water just pulls the sugar molecules apart instantly to form the solution. If the crystals are slightly bigger and settle at the bottom, the shielding starts forming again. This is exactly why stirring helps. Stirring sweeps away that sticky syrup shield and lets fresh solvent rush in. So there you have it. Powdered sugar wins the race because it uses massive surface area to give the solvent more place to attack, and it spreads out so it never gets trapped in the own sticky syrup shield. Next time you are in the kitchen cooking potatoes or making sweet tea, remember the surface area of powdered substance and the boundary layer effect. If you loved learning the concept this way, provide your feedback in the comments and write to us if you are struggling to understand any concept. Details are given below in the video description. We would love to make them easy for you to understand. Until next time, take care.